Next, I want to take you through an example of how we do a trapezoidal approximation with an equation instead of a picture. The equations are always going to be the ones that are going to take you the most amount of time, so I won't do as many of them. So first, let's talk about how we create this. So we are going from 1 to 3, and we're splitting it up into 4 subintervals. So I do like to draw a number line. So we're going from 1 to 3, splitting it up into 4 subintervals. So that means each one has to be 0.5 wide. So I'm still going to put that somewhere that my width is 0.5. That actually is going to make up the height of the trapezoid. So your formula for trapezoid is half of the height times the bases added together. So your height is actually going to be what we've been calling the width of the rectangle. Your bases are going to come from putting those different x values into your function. So when I actually draw them, I was pulling them up from the bottom all the way to the function. When I actually calculate them, I'm going to plug them into this function. So think about with my trapezoid. So my first trapezoid is going to be here, my second trapezoid is going to be here, my third trapezoid is going to be here, and my fourth trapezoid is going to be here. In my first trapezoid, the first base that where x is 1 is going to be used and 1.5 is going to be used. My second trapezoid, you're going to use 1.5 and you're going to use 2. My third trapezoid, you're going to use 2 and 2.5. And my last trapezoid is going to use 2.5 and 3 as your x values that create your bases. So notice what happens. Your first base and your last base only get used once, meaning they only get plugged into the function once. All of your interior bases, in this case 1.5, 2, and 2.5, those x values, are actually going to be a base of the trapezoid to its immediate left and to the right. So the fastest way to do this on your calculator is to calculate that base double, to calculate the first base and the very last base once and all the interior bases twice. So here's what this is going to look like. So with my calculator, so my function is 5 square root of x. So first I'm going to put in 5 square root of 1, which I do very much realize is just 1. But then I'm going to add to it 2 of your 5 square root of 1.5 because it's going to be a base of both parabolas. Or both trapezoids. Got parabolas in my head. And then I'm going to have 2 of the 5 square root of 2. And then I'm going to have 2 of the 5 square root of 2.5. As you can see, this is tedious. And then you're only going to have 1 5 square root of 3 because it's only a base of the very last trapezoid. So that's going to give you all of those bases added together. Now don't forget the formula is 1/2 times the height times all of this. So you have to take that answer times 1/2. And then you also have to take it times that width we found, which was also 1/2. So we're going to take that answer times 1/2 for the formula and 1/2 for the height. And we get 13.965. So let me put this in here and then let's take a look at how they write it out, because maybe they write it out in a way that makes more sense to you. So they found the width. They do have a picture, which is nice. So we're putting in 1 and 1.5. Then we're putting in 1.5 and 2, and then we're putting 2 and 2.5, 2.5 and 3. I kind of streamlined it. I also realized that we're always multiplying by 1/2. And then we're always doing 1/2 with the formula. So all these 0.5s are your widths, and the fact that it divided by 2, that's just averaging your bases. So base 1 plus base 2 divided by 2, base 1 plus base 2 divided by 2. I think that the way we enter in the calculator is probably the most efficient way to go through that. So that is your trapezoid rule by equation.